This lecture is about use of Euler's equation of motion. A few months back, in this YouTube channel, name of the channel is SSSD Sciences. In this channel, two videos were posted. One video was about derivation of Euler's equation of motion along a streamline, and the next one was same thing, means Euler's equation of motion, but it was not along a streamline. It was along Cartesian coordinate system, means it was derived in Cartesian coordinate system. So equation was along x-axis, y-axis and z-axis, where x, y and z are the three axes which are perpendicular to each other, and they are called rectangular they makes a rectangular Cartesian coordinate system. So in first year BTech course, one subject is there, engineering thermodynamics and fluid mechanics. I've seen that many of the students make the same mistake, that instead of using the full Euler's equation of motion along a streamline to derive Bernoulli's equation, they use a part of it, and I think that is wrong. Euler's equation of motion is actually applicable for steady as well as unsteady flow. That means time must be there in the equation. The part time derivative is there. Okay, partial derivative of time, partial derivative of velocity with respect to time is there. It is present in Euler's equation of motion. Okay. And this is written in actually partial differential form, not ordinary differential form. This equation, Euler's equation of motion. You can follow any book, but the books which are written for only first year courses, I think those books are not so much suitable to know the details about Euler's equation of motion. You can follow other books, even the book written by R.K. Bansal, that is also not wrong, but not correct also. You can follow any other book written by Bachelor, book written by Sombisas and Chakraborty, etc. Good books are there. In any institute, few good books are there. So, or you can go to Google to search full Euler's equation of motion. I am not going to show this thing here. Anyway, the full governing equation in fluid mechanics, the name of that equation is Navier-Stokes equation. And here you have seen Euler's equation of motion. Only the first year students, you have seen Euler's equation of motion. So what is the difference between these two equations? There is only little difference. So mathematically, this difference is huge. But physically, what is the difference? Difference is that in Navier-Stokes equation, I am talking about only the momentum equations, okay? Which was derived using Newton's second law of motion. Force is equal to mass into acceleration. Or I should rather say, and it would be correct to say, that force is equal to rate of change of momentum. So using that Newton's second law of motion, both Euler's equation and Navier-Stokes equation were derived. Difference between these two is, in Navier-Stokes equation, all the terms are present. All the necessary terms are present, but in Euler's equation of motion, only one term is absent, and that term is terms due to viscosity. Means during the derivation of Euler's equation of motion, viscous terms are neglected. So is this equation wrong? Euler's equation of motion? No, not wrong. You cannot say that this equation is wrong because all the fluids are real. There is no imaginary fluid, no ideal fluid. All the fluids are real and all the real fluids are having some viscosity. So how can you neglect the effect of viscosity? Yes, it can be neglected. In case of high velocity flows, this term can be neglected. That is the viscous term. In Navier-Stokes equation, the terms which are called convective terms like U del U del x, V del U del x, W del U del x, where U, V, W are the velocity components along x, y and z directions. These terms are very, very greater than the viscous terms. So since these terms are very, very greater than the viscous terms in case of high speed flows or high velocity flows, so in that case, it is very easy to neglect the viscous terms. So the question is where it is suitable to use Euler's equation of motion? In case of high speed flows. So how you will decide which one is high speed flow, which one is low speed flow, where Navier-Stokes equation should be applied, where Euler equation should be applied to get the desired accuracy. So to distinguish between these two, one dimensionless number is defined. You have heard that number. That is called Reynolds number. Reynolds number, which is denoted by rho multiplied by V multiplied by L divided by mu, where rho is density of the fluid, V is the velocity of the fluid, and L is the characteristic length of the flow domain, and in the denominator appears mu, which is viscosity. Viscosity means here it is dynamic viscosity, coefficient of dynamic viscosity, not kinematic viscosity, mu. So Reynolds number, first you have to calculate Reynolds number, and depending upon the value of the Reynolds number, it is decided whether Navier-Stokes equation should be used for the given problem or Euler equation of motion should be used for the given problem. So the deciding factor is the Reynolds number. And you will see that here in the numerator velocity appears. So when velocity is more, Reynolds number will be more. Okay. So for high speed flows, Reynolds number will be much more. The value will be very high. So you have to follow literature. Literature means same works done by other scientists or other researchers for a given problem. And if the problem is totally new, then in that case, you have to do numerical experiments. Okay. And you cannot say that why we will go for Euler's equation of motion. We can, where Navier-Stokes equation is available, why we should go for Euler's equation of motion. Actually, cost is involved here. When you are going to solve Euler's equation of motion, the time required to solve the equations are very less as compared to the solution of Navier-Stokes equation. And you know that time is money. Say for example, using a computer, you are going to solve Navier-Stokes equation, and it takes 10 days, means 10 days multiplied by 24 hours, 240 hours. And when you are using Euler's equation of motion, it takes hardly 3 days. So 3 into 24 is equal to 72 hours only. And the company is paying you money for each and every day. Say per day you are getting 5,000 rupees or 10,000 rupees. Now you can easily guess that in all the cases we should not use Navier-Stokes equations. Which equation should be used, which equation should be avoided, which equation should not be used. All these things depend upon the requirement. Requirement of what? Requirement of accuracy. When you are going to calculate flow through a drain, and when you are going to calculate flow over an airplane, you can easily guess that these two problems are totally different. A small mistake in the calculation of airplane, it might prove to be very dangerous. But in case of flows through drain, you can easily guess. So, ultimate conclusion is that there is difference between these two equations, Navier-Stokes equation and Euler's equation of motion. And during the derivation of Bernoulli's equation of motion, using Euler's equation of motion, you should write the full Euler's equation of motion. Okay. Okay, thank you.